the exam materials. So click on that. Exam materials, you're going to go to exam 4 materials. You're going to click on study resources. You'll notice another thing here. I put up like 23 new tutorials yesterday. So if there's a concept that you're kind of shaky on, there's probably a tutorial on it. So if you look here, you'll find all these tutorials. And then there are these lectures as well. Some of these lectures are appropriate there. Some of it goes over stuff we didn't go over. It doesn't match exactly, but okay. So here you'll see the practice exam. Click on exam 4 review sheet. You guys will probably want to click here, the little down arrow, and click download so that you can type on the worksheet. I'm going to be using a whiteboard, so I'm not going to be doing the not going to be typing on that in there. Okay, but feel free to type on it. All right, you have a question.
So I have a question. I mean, are the questions will be similar like you have on the worksheet?
Yes. They should be similar to the ones that I have on the worksheet.
But
they may be worded a little differently. Oh, go ahead.
Oh, sorry about that. But the numbers will be different, right?
Yeah, the numbers will be different. The questions may be different. Like, I'll definitely have these types of questions. So, oh, Erin, there are a couple of tutorials on molarity that will probably help you with the molarity. If you go under study resources and click on tutorials, scroll through there and look for the ones on molarity. Okay, so for example, I'll have balancing questions, I'll have stoichiometry questions, and that kind of thing. It won't be this exactly with just numbers changed, but it'll be these kinds of questions, if that makes sense. Let's see. A lot of the test is definitely going to be math. There will also be concept questions, though, so make sure you study those as well, but there are definitely going to be a lot of math questions. Because it's stoichiometry, and stoichiometry is it's just a lot. I mean, it's not just a lot of math, but there is a lot of math in it. Concept questions, kind of like, let me think. Now that you've asked me, I can't think of one concept question. I guess things like the idea of limiting reactant and what's the purpose of a percent yield and those kinds of things. So like why do you care what the limiting reactant is? What is the limiting reactant? And that sort of thing. So we're going to balance this equation. Oh, goodness gracious. I wrote too big. Let me do that again. Let's see. I think there's actually a list of concepts. If you go in the textbook and you go to the end of the chapter, look for the section called Summary. You can find this on the online book or in the actual book. And in Summary, part of it is concepts. And it will review all the concepts that you need there. All right. So we got iron, bromide, and sulfuric acid, making iron sulfate. plus, I'm still running out of room, HBr. Okay. So the first thing we've got to do is count everything on both sides. And I noticed one thing that's going to help me a bit. I see there's sulfate, which is a polyatomic ion right here and right here. So it's on both sides. So I can treat sulfate as one entity instead of breaking up the sulfur and the oxygen separately. Now I can break up the sulfur and oxygen separately if I want to, but if I keep them together in this case because they're polyatomic ions, that's probably going to make it a little bit easier for me. So I've got iron, bromine, hydrogen, and sulfate. So let us, oh, that was not a straight line. All right. I always like to draw the middle line right there at the arrow as a good separation. So how many iron do we have on the left? 1. How many iron on the right? 2. How many bromine on the left? How many on the right? How many hydrogen on the left? And on the right? And how many sulfate on the left? 1. And how many on the right? 3. Good. So let's balance it. There's not a particular order that you have to balance it in, unless you're doing hydrocarbon combustion reaction, which is then carbon, hydrogen, oxygen. But in this case, I just like to balance them. I just like to balance them in order of how they appear. But you don't have to do that. You can balance them in pretty much any order. One thing I noticed that just looking at it, if I try to balance the bromine first, I have 3 on left, then I would put 3 in front of HBr, but then on the left I have 2 hydrogen. So then trying to match the 2 and the 3, that kind of becomes kind of hairy. But if I do the iron first, then life is a little bit easier. So if I have 2 on the right and 1 on the left, I'm going to change the coefficient. Remember, never change the subscripts, only the coefficients. Coefficients are the numbers out front. So now if I recount, I've got 2, 6, 2, 1. So now let's balance the bromine. I have 6 bromine on the left and only 1 on the right. So I'm going to put a 6 here. And I still have 2 iron, still have 3 sulfate. I have 6 hydrogen and 6 bromine. So that looks pretty good. My hydrogen's now off. So I'm going to put a 3 here. And this is going to change. So I have 2 iron still and 6 bromine. And now I have 6 hydrogen and 3 sulfates. So when I'm counting these up, remember that my goal is to get this and this to match because of the law of conservation of matter. I know it is so messy. It's usually neater when you guys do it than when I do it. Mine is messy. Sorry about that. I've worked on my handwriting my whole life. It does not get better. I've tried. Of course, that doesn't mean I should stop trying, but kind of given up on that whole idea. Sadly, it doesn't matter if it's a computer, the dry erase board, or just a simple sheet of paper. It all looks the same. Okay, so when you're counting like the bromine, remember it's the coefficient times the subscript, right? That's how I got 6. And for iron, it was the coefficient times the subscript, and there was no subscript, so we're assuming that's a 1. Okay? Yeah, I don't know how artists do it on a computer either. That, to me, seems nearly impossible. Anybody need a second on this page? Yes, okay, Arif needs a second. Just let me know when you're ready, Arif. So you good, Arif? Okay. I wasn't sure if you meant, okay, I'll let you know when I'm done, or okay, I'm done. So, sorry about that. All right, so we're going to do another one. This one's going to be the hydrocarbon example. This example I like because I didn't tell you what the products are. So it's kind of harder. Not a lot harder, just a little bit. As a matter of fact, I don't even have to tell you that it's mixed with O2. I could just say, exactly, you're correct, Hunter. I could just say the combustion of C2H4. And then you should know that that means that C2H4 is mixed with O2 because I used the word combustion. And then since it's a hydrocarbon, I'm going to have CO2 and H2O as my products. And since it's combustion and everything's really hot, I'll probably have gas for my water. Oxygen is a gas. I don't actually know if C2H4 is a gas or a liquid. If it was a little bit smaller, I'd know it's a gas for sure. A little larger, I'd know it's a liquid, but I don't know on that one. That would have been given to you on that anyway. Okay, so we're going to do the same thing, but this time we're going to do it in this order. C, H, O. And I can't think of like a saying or anything to remember it, but just, oh, it's alphabetical actually. C-H-O. Yeah, do it alphabetically. That works. I never noticed that before. I always try to look for patterns in things because I'm terrible at memorizing stuff. If I don't have a pattern, ugh, I'm not terribly good at it sometimes. Yeah, right. Actually, it would be right to left. And, unless, of course, they put the oxygen first, but that's very rare. So, yeah, right to left. All right, so on the left, we have 2 carbon. How many hydrogen do we have on the left? How many oxygen on the left? All right. And on the right, how many carbon? How many hydrogen? And how many oxygen? 3, good. This can be easy to forget that if you're looking at the oxygen here, that there's also one here, or if you're looking at the one in water, you might forget that there are some in carbon dioxide. So that's a good thing to keep in mind. All right, so let's see. We need to know the different classifications of reactions and how to differentiate them. Like, no, you don't need to know that for this. It's good to know it for the final exam. Because sometimes the final exam will have different questions on it that we may not have gone over, which is part of the reason that it's curved. But it doesn't matter, like if you know something that we didn't go over and you get that correct, you still get the points for it. So it's good to know to go through, like as you're going through the ACS book over the next week or two, make sure that you're, even if we didn't cover it, go ahead and see if you can go through the practice chapter and read about it and then maybe figure it out. Not normally. I mean, with the different gases, like carbon dioxide, you know is a gas. Oxygen, you know, is a gas. Things like that, things that are really common. But to know whether or not ethane or C2H4 is a gas or not, You'll know that more when you get into organic than you would know right now. All right, so we're going to make this, we're going to balance carbon first. So now we have 2 carbon, and then we have 5 oxygen, and still 2 hydrogen. So what will we do now to balance the hydrogen? Any ideas? We have 4 on the left and 2 on the right. Correct. Put a 2 right in front of the H. And now we have 4, because it's 2 times this 2 makes 4. So we have 2 carbon, 4 hydrogen, and 6 oxygen. All right, we're getting close because this matches and this matches, only off on 1. Haha, 3 in front of the oxygen. Very good. All right, so then that's going to be 2, 4, and 6. And so now we're completely balanced, and that's all you had to do with that one. All right, anybody need a second on this one? No? Okay. All right, so now we're going to just answer a couple of just little questions about an equation. Well, I don't know if that would be aqueous. It's probably a solid. So there's no water involved. Is there any reactions other than combustion that we need to know? No, not really. Not for this exam. I mean, if you have a reaction, like for the final exam, if you had a reaction where you had X plus YZ, there's pretty much only one thing that's going to happen. Now, it could be that you get XYZ, or everything could fall apart. You can have X plus Y plus Z. Most likely, you're going to get XZ plus Y. But as far as this exam, no, you don't have to know that. And you don't have to know it on the final exam. That's why it's curved, but it's nice to know those extra things. All the points you can pick up here and there, the better. Especially if you can learn a simple concept that you might not know now, that could correct for a more difficult concept that you might struggle with later. Yes, in combustion, water is always a gas. The reason is because combustion is like an explosion. It's burning in fire, and so it's going to have just a little bit of water that's produced, so it's going to burn that water. All right, so the question is, what's the ratio of, so I'm going to write down some of this, ratio of moles of iron to chlorine gas. All right, 2 to 3, perfect. And so where this is coming from, the 2 and the 3, here and here. There are 2 iron to every 3 Cl2. I wrote it like this here just to remind you that it's a molecule. If you're counting the number of atoms, there are 6 chlorine atoms, but when you're looking at the molecule, there are only 3 molecules. Does that make sense? Did I throw anybody off there? No? Okay. All right. I should have actually written on that, answer the question below, because I only gave you one question. All right, so the next one, we start getting into the equations. Let me clear this. All right, and this one is 2H2O plus 2H2. What? That is crazy. No. Make a correction on your worksheet because what I wrote up there is not an equation. I wrote 2H2O plus 2H2 plus O2. That's not what I meant. That would just be totally confusing if you sat down with that. If you take H2O and you don't just heat it, but you give it electricity, you can break it apart into its elements. And the elements are hydrogen and oxygen. So, I mean, you can do it the opposite way too. You can take H2 and O2 and make water with it as well. Did I do it on the next page too? Oh, for crying out loud. Okay. Sorry about that, guys. If you run across one like that has no arrow in it, the only one I meant to have no products was the very first one that we worked already. The rest of them should all have products, and hopefully you can figure out where I meant the arrow to be. I'll see about if I have time later, I'll try to go in and correct those and upload the corrected file. But if not, just remember I'm not expecting you to just guess what the products are. So, okay. So how many moles of water are needed to produce 55.7 moles of H2? Right? So we don't know how many moles of water, and we have 55.7 moles of H2. So what am I going to write down first? What's the number that I'm going to put down on my paper first? Yes, 55.7 moles of H2. Did I? I'm not surprised. Oh, I sure did. Okay, we'll go back to it. Sorry. Okay. All right. So I'm going to have moles H2. I need it on the bottom because I've got moles on the top, so I need moles on the bottom, so we'll cancel. And I'm trying to find out about water, so that's going to be on the top. And when I go moles of one thing to moles of something else, I'm going to need coefficients. So when when I have an equation, I'm going moles of one thing, moles of something else, I use the coefficients. So in this case, there are 2 water, and I'm getting that from this number, and 2 hydrogen, and that comes from that number. All right, so it's a 2-to-2 ratio or a 1-to-1 ratio, so it's going to be the same number. It would not be the same number of oxygen. It would actually be a 2-to-1, so it would be half as many oxygen molecules. All right. Anybody need a second on this before I go back to the one I just missed? Or just skipped? Yep. Okay. Just let me know when you get ready, Summer. You mean the 2 right here? That's actually the coefficient. Thanks, Summer. That's the coefficient, because if I'm going moles of A, which could be moles, I just mean moles of one thing, anything, to moles of something else, and I have an equation like this, then I'm going to use my coefficients. Correct. If I wanted to convert to grams, I will use molar mass. And I think that's actually the question that we have. Maybe the question we have above it. No, it's another question of moles. So we're going to do something pretty similar. Correct. That is correct, Walter. All right. So again, we have 2H2O plus, not plus, oh my gosh. 2H2 plus O2. We have 1.26 moles of oxygen, and I want to know, not of oxygen. If I read my question correctly, it says water. All right, so 1.26 moles of water is reacted. How much oxygen is produced? Good. So I'm going to put moles of water on the bottom. This should be O. And then moles of O2 on the top. And I'm going to get these coefficients. Put this one here. And then there's no coefficient there, so really I know that it's a 1. So I'm just going to divide that by 2. So 1.26 times 1, and the answer divided by 2. All right, good. Very good. All right, so let's move on to the next section, or to the next question. Oh, cool. All right, the next question is nice because it's worded kind of weird. It says, I'll try to write the whole thing down, and then I'm going to clear the page and we'll work it out. Okay. If enough, H2O is reacted to produce all right. So I'm going to put a circle around all the information they give me. All right? They give me 3.40 moles of H2, and I have enough water to produce it. So they don't tell me how much water, they just said I have enough to produce this much hydrogen. And they want to know how many moles of oxygen. Is it a problem that they didn't tell me how much water I have? No, and why not? I don't actually need the amount. Correct, I don't need the amount of water here because they gave me what I need. They gave me moles of hydrogen and they're asking me about moles of oxygen. So all this water stuff is just something that can throw you off in a question, so. Correct. All right, so let me take that real quick. Okay. Caspian is like, I got it. All right, he's quicker than me. All right. And then H2, 2 moles, H2, 1 mole, O2. And that's coming from the coefficients. And that is 1.7. So it's basically 3.4 divided by 2. And that's going to be 1.7 because 1.7 times, well, that's math. You know that 1.7 times 2 will be 3.4. Okay. Areeb, you have a question.
How do you know it's 2 moles of H2? Did you balance the equation?
Yes. So you might be given a question, something like this. And then ask questions about it. And the very first thing you want to do with every single question is make sure it's balanced. Now, if you see there are coefficients, it's almost certainly balanced, but it's always good to check. So if I'm looking at this here, I'm noticing that I have 2 oxygen here, but only 1 there, so we have to put a 2 here. But then that doubles my hydrogen, so I'm going to put a 2 right there. So that's going to be how I would know what the coefficients are for that. Do you have another question?
Yes, ma'am. So is it always good to put it into equation form and then solve it?
Yes. Yes. Very much so. Especially if you're a visual person. Some people may be able to kind of think it through in their head, but with me, even if I can think it through in my head, a lot of times I will get it mixed up if I can't see the equation, so I always write the equation down. Essence, you're correct. In this case, the equation is given. Yeah, okay. Correct. Yeah, so if you look at the worksheet, it gives you the equation at the top, and the equation should say 2H2O arrow 2H2 plus O2. I put a plus sign, I don't mean that. And then there are 3 questions that have to do with that same equation. All right, and then the next question, you're going to balance the equation, and then you're going to work a limiting reactant problem. All right. So here is our equation. And again, I put a plus sign. I don't know why. There should be an arrow after the sodium nitrate. Oh, I put plus sign crazy. It was like plus, plus, plus. I don't know what I was thinking. Okay, so we're going to balance this. It's got copper, chlorine, sodium, and nitrate. Now, if I didn't know that NO3 was a polyatomic ion, I could still do nitrogen and then oxygen, right? It would still balance. This is just a little bit quicker. All right, so on the left, I have 1 copper, 2 chlorine, 1 of each of these, 1 copper, 2 nitrate, 1 sodium, and 1 chlorine. All right, so I'm going to try balancing the chlorine first. Then I'll put a 2 here. Actually, I should change the color so you can see it more clearly. So the 2 is there. So that's going to make 2 of those. Okay. Now I'm going to balance the sodium on the left. So that's going to be 1, 2, 2, 2. And if you look here, balanced, balanced. So 2 in front of the sodium nitrate and a 2 in front of the sodium chloride. Anybody need a second on this before I switch to the next question? Or to the next part of this question? Yeah, okay. Just let me know when you're done.
Hello.
All right. So write that again. CuCl2 plus 2NaNO3, arrow, not a plus sign. CuNO3, 2 plus 2 NaCl. I think I wrote that correctly. Yeah, it looks good. Okay. So the question now is becoming a limiting reactant problem. It says if 15 grams of copper copper chloride, react with 20 grams of sodium nitrate, how much sodium chloride can be formed? All right. So if they give me an amount of both reactants and they don't tell me which one is in excess or which one is the limiting reactant, I have to figure out which is the limiting reactant. If it's a problem where they only tell you how much of one thing they give you, most likely it's not a limiting reactant. They're assuming you know the other one is in excess. So this one tells me about the copper chloride and about the sodium nitrate. So that's limiting reactant. So I'm going to find out how many moles of product can be formed. Now, it doesn't matter if I choose copper nitrate or sodium chloride, as long as I stick with the same product. But in this case, the question's specifically asking about sodium chloride, so I'm going to go ahead and convert to sodium chloride. So we've got 15 grams copper chloride and 20 grams sodium nitrate. All right, so what's my first step? I'm going to go grams to what? To moles, correct. And if I go grams to moles, what do I use? Molar mass, good. All right, and so for the copper chloride, what is the molar mass of copper? I don't know that one. I know chlorine. That'll be chlorine. 63.55. Oh, Hunter's got the whole thing. Hunter says 134.45. And let's see. How many moles is that? Grams per how many moles? 1. All right. Now we're going to do the next step. And in the next step, where do I go? We'll do the sodium nitrate here in a second. Mole ratio. Correct. I'm going to go over to moles of sodium chloride. All right. And the coefficient next to copper chloride is assumed to be a 1. And the one in front of sodium chloride is a 2. So what is our answer there? It's going to be 15 times 1 times 2. So it'll be 30 divided by 135.45 times 1. 13.0 grams or moles? Moles. Okay. All right. And if you were looking at these questions later and you get something different in the calculator, we don't have to go to grams, actually. Okay, so Josh says it's 0.223 moles. That sounds about right. I think he went all the way to grams. I think you're right. He's fast. All right. So I'm not checking these numbers in a calculator. So if you get something different in your calculator, just keep that in mind. Okay. All right. So we got that part. Now we can go all the way over to grams of sodium chloride. We don't have to at this point because that would be an extra step. And let's not do extra step. All right. So for sodium nitrate, it's, I think sodium is 23. Somebody look up sodium. Yep. Dolores gets 84.99. Is that what everybody gets? Yep. Okay. All right. And that's going to be 1 mole Na3. Now for the next part, we're just going to convert from one thing to another. So we're going to convert from moles of NaNO3 to moles of NaCl. 2 moles for what? Using the sodium nitrate? Yeah, that's only when you go from moles of one thing to moles of another. So it is going to be 2 here. But in this case, we're doing molar mass, and molar mass is always grams per 1 mole. So you only use the coefficients when you're going moles of one thing to moles of something completely different. All right. So what is our answer to this part? How many moles of sodium chloride do we get here? 0.235. So which one is the limiting reactant? The copper chloride, correct. How do I know that? Less, correct. 0.223 is less than 0.235. So that means copper chloride is my limiting reactant. All right. So it's asking how much sodium chloride can be formed. It's not specific saying how many grams, how many moles. So we're just going to stick with moles for time's sake. And the answer to that would be 0.223 moles. Now, if it indicated it wanted to know how many grams, I would go one further step and convert it to grams using the molar mass of sodium chloride. Does that make sense? Ah. It's 10:58. That's so weird. Every day. Okay. Give 1 second. So weird. Where is my computer? Circle back. Where is it? There. Oh, so you can hear me now? The reason it would be 223 is just checking. See if I can fix this real quick. Maybe if I drag it over the other screen, that might help. Okay. So, can you hear me better now? No. Sorry. Okay. I'll just put it in the chat.
So